So welcome students. So continue to our last lecture. Let us discuss some more problems. So this is a problem. Suppose 4-degree equation is given, d power 4 minus 5d square plus 4 into y equal to 0. So you need to solve it. For that the auxiliary equation is d power 4 minus 5d square plus 4 equal to 0. Now you see that there is no cubic term, right? So 4, 2, then 0. So if you put d square, and if we can make it d power 4, you can make it d square whole square, right? So if you let x equal to d square, then you need to consider this as a polynomial equation. So we can write like x square minus 5x plus 4 equal to 0, right? Now you see that 4 plus 1 equal to 5. So the x square minus 4x minus x plus 4 equal to 0. So if we take common x from these two terms, so you get x of x minus 4. If we take minus 1 common, then you get x minus 4 equal to 0. So ultimately we get x minus 4 into x minus 1 equal to 0. Now if you again put x equal to d square, so this you get d square minus 4 into d square plus 1 equal to 0. Now d square minus 4 equal to 0 implies d equal to plus minus 2, and d square minus 1 equal to 0 implies d equal to plus minus 1. Now all these values plus 1, minus 1, plus 2, minus 2 are different. So the general solution is c1 e power twice x plus c2 e power minus twice x plus c3 e power x plus c4 e power minus x, where c1, c2, c3, c4 are arbitrary constant, right? Okay. Now I believe that you have understood the concept. So according to the problem, you need to decide how you solve it, right? So suppose this problem is given, d power d3 minus 3d square plus twice the whole into y equal to 0. Now auxiliary equation is this, okay? Now here constant term is not there, so you can take common d, right? So if you take d common, then what you get, d square minus 3d plus 2 equal to 0. So this is a quadratic equation. So 2 plus 1 is 3. So d square minus 2d minus d plus 2 equal to 0. So you get d minus 1, d minus 2. So what are the solutions? D equal to 0, 1, 2. So all these roots are distinct. All these roots are distinct. So how we write the general solution? c1 e power 0x plus c2 e power x plus c3 e power twice x, right? So general solution is y equal to c1 plus c2 e power x plus c3 e power twice x, where c1, c2, c3 being arbitrary constant. Okay. Next, you need to solve this d cube minus 8 of y equal to 0. So the auxiliary equation is d cube minus 8 equal to 0. So you can write x square minus 2 cube, right? So this is x cube minus a cube. So you know that x minus a into x square plus ab plus b square. Okay, so you get d equal to 2, and from here you can directly put this minus b plus minus root under b square minus 4ac by twice a. So by this way you get minus 1 plus minus I root 3. Minus 1 plus minus I root 3. Now you have what? One root is real. Okay, so for this you have to write c1 e power twice x, and another two roots are one pair of complex solution. So how we need to write the solution? Okay, e power minus x, right? E power minus x into c2 cos root 3x plus c3 sin root 3x. Okay, so this is your required solution, where c1, c2, c3 being arbitrary constant. c1, c2, c3 being arbitrary constant, right? So if we take d equivalent to ddx, so how we write? D power 4 plus m power 4. Okay, so this is like x to the power 4 plus a to the power 4. Okay, so this is like x square plus a square. So x plus a whole square minus twice ab. Now this can be twice ab can be written as root 2 dm whole square. So again this is like x square minus h square. Okay, so x plus a into x minus a. So x plus a this, x minus this. Okay, so this is a cubic equation, d square plus root 2 md plus m square. Now its solution is what? D equal to, you just do it, minus a plus minus root under b square minus 4ac by twice a. Okay, by this way you get this these two roots, and from the second one you get these two roots. Okay, right? Now how you write the general solution? Here two pair of roots. Okay, so for first pair you have to write e power minus mx by means minus e to the power alpha x, right? So alpha is what? Minus m by root 2. So e to the power minus mx by root 2, and another is thing c1 cos mx by root 2 plus c2 sin mx by root 2, right? And for second pair you have to write e power mx by root 2, okay, e to the power alpha x, so e to the power mx by root 2, and then c3 cos mx by root 2 plus c4 sin mx by root 2, where c1, c2, c3, c4 are arbitrary constants. Okay, and the next one is a particular values of m, that is 1. Okay, so suppose in exam this question has come. Okay, so how you solve it? D power 4 plus 1, so that means you have to write like this: d square plus 1 whole square minus root 2d whole square. So then you proceed same way. Okay, similarly this problem is given d power 4 minus m power 4 equal to 0. So directly you say that it's like x square minus a square. Now if you put x square equal to d square, x equal to d square, then it is like x square minus a square. So this is x plus a into x minus a. Okay, so d equal to plus minus m and d equal to plus minus im. The one is two roots are real, two roots are imaginary, and also you know that imaginary roots are occur in conjugate in pair. That means one is plus im, another is minus im, right? So for real roots are distinct. Huh? So how we write the solution for real roots? Okay, c1 e to the power mx, right, plus c2 e to the power minus mx. And for complex root, here what? 0 plus minus im, na? Alpha value is 0. So e to the power, here alpha value is 0, beta value is m. So e to the power 0x c3 cos mx plus c4 sin mx. Okay, so how you write the final solution? c1 e to the power mx plus c2 to the power minus mx plus c3 cos mx plus c4 sin mx, where c1, c2, c3, c4 are arbitrary constants, right? Okay, so here is what? D square plus 1 whole square, that means d square plus 1 twice. Okay, that means whatever the solution, that will be twice. So that means d equal to plus minus I, that is twice. Okay, so two pair of equal roots, right? So as per our formula, how we write the solution? Y equal to e to the power, because alpha value is 0, so e to the power 0x, and for these two pair of equal roots we have to write c1 plus c2x cos x plus c3 plus c4x sin x. Okay, that is where c1, c2, c3, c4 are arbitrary constant. That is your solution. Okay, and this problem is again given to you, and this is square, means this is twice. So you just use d equal to minus b plus minus root under b square minus 4ac by twice a formula, and you get 1 plus minus twice a, which will be twice times. So your solution is e power alpha x, that is e power x. And for plus minus twice a, how you write this? c1 plus c2x cos twice x plus c3 plus c4x sin twice x, where this c1, c2, c3 and c4 are arbitrary constants. Okay, so here cubic okay, fourth order equation is given. So if you take d common, then this you will get d cube minus 6d square plus 12d minus 8, and yeah, you need to solve it, right? So if you put d equal to 2, then the left hand side becomes 0. So d minus 2 is root, and you can see as I did for a workout solve problem. So you just do the same techniques and you get this. Okay, d minus 2 of d minus 2 3 times, then put by multiplied by d square. Okay, then multiplied by minus 4d plus 4. So similarly you get this. Okay, so I believe that you got some informations about how to solve the problems. So ultimately we got like d equal to 0, 2, 2, 2. Okay, so required solution is what? Y equal to it. So one is distinct and all three are same. So c1 e to the power 0x plus c2 plus c3x plus c4x square e power twice x. That is your solution. Okay, where C1, C2, C3 and C4 being arbitrary constants. Okay, so do these problems, do this exercise. Okay, there are some more problems, solve problems are given to you for your practice. So first practice all the solve problems, then come to this exercise 5a, and I believe that you can do all the problem. Okay, so if you have any doubt or if you are not able to understand anything, then let me know. Okay, so thank you all. Okay, meet you in next lecture.